Good evening to all of you. Welcome you guys. Welcome you all. Yes, I think we are live. First of all, do comment करके बोलिए. Is the audio videos clear to everybody? Right. Chalo. Yeah, first of all, let's continue our discussion. So here before that, so we have a great announcement from Unacademy. So this is the student who are preparing for 2027, 2028. So there is a golden opportunity. So you can start your serious preparation kit that is just 9,999 only. Utilize this opportunity before going to expire. There is a chance to get 60% of discount आपको मिलेगा. Right. So to enroll for it, you can use the code of BV Reddy and to avail this great discounts. So चलिए आज का सेशन शुरू करेगा हमने. And another thing is, so there is a 3 days free live class festival we are planning. So with this, you will get to know how the Unacademy platform we can able to interact with this thing. You will get to know. So 3 days, 3-day free live class, attempt interactive polls, get your doubts are cleared. So that is from April 9 to 11. The 3 days free classes are running. And so you can see now here. So the test series which we are planning, Unacademy scholarship test for 2027, 2028 के लिए there is a chance to get 90% of a scholarship आपको मिलेगा. So the exam is on 19th April. 2 sessions are there, 11 a.m. and 5 p.m. So do enroll completely free. And so we're starting a new batches. Yugantar batch from that is at the 10th April. And Mahavir batch. And rank improvement batch also we have started. You can have a look at. These are the Unacademy Gate 2026 rankers. You can see now. All these are the EC and electrical rankers only. In top 100 only, you can see now how many rankers are there. The rankers will talk about the Unacademy. So these are the ESC 2025 rankers. You can have a look at. And Unacademy UNA. So there are 3 modes are there: voice mode, quiz mode, and test series, smart summary mode. The test series is available, and we do offer 2 subscription. One is a plus, the other one is a iconic. Plus में आपको क्या चीज मिलेगा? टॉप एडुकेटर्स क्लासेस मिलेगा, लाइव डाउट सॉल्विंग, evaluated test series, structured courses PDF, and live test, and unlimited access. You can watch the class any number of times. And iconic में एडिशनली आपको क्या मिलेगा? पर्सनल कोच भी मिलेगा, एज वेल एज फिजिकल नोट्स भी आपको मिलेगा. Right. So chalo, let's start our discussions. These are the 2025 rankers. So here last class we did some problems now. So we'll continue the remaining problems. Okay? Yeah, take the next one. A point charge Q1 which is equal to 4Q0 is placed at origin. Another point charge minus Q0 is placed at x is equal to 12 centimeters. Charge of proton is given as Q0. Okay. The proton is placed on x-axis so that electrostatic force on the proton is 0. This situation, the position of proton from the origin is. So there is some disturbance, you are not able to see the problem now. I will drag it. Okay, will it be fine now? Now you can able to see the problem. Right, so see this thing here, a point charge of what they given now here, and we have a charge. So this is one is we have given it as a, this is, if I call this as a Q1, is placed at origin. Another point charge which is located, another charge, if I call this is a Q2, and this is located where you tell me now here, this charge is 4Q0, and this is what you tell me now here, Q0, right? And these two are separated by a distance. How much the distance is separated now here? 12 centimeters they given. Now, what they asking to find now here, the proton is placed on x-axis so that electrostatic force on the proton is 0. The force on the proton is 0. That means they asking to find equilibrium point. So this is minus, no? Okay. Here this is minus Q0. That means they are asking to find what, tell me now here, electrostatic force is 0 means equilibrium point. Now since here two charges are what type of charges now? Like charges or unlike charges? These are the like charges. Unlike charges. Unlike charges of different polarity. For unlike charges, different polarity charges, equilibrium point lies outside the two charges, and near to bigger magnitude, near to bigger value, heavier body, or we can say bigger charge. So this will be lies to here where you can see now here, and so this will be equilibrium point outside the two charge and near to smaller magnitude of charge. Okay. Yeah, you can tell me now here. So this is smaller magnitude, so that means it will lies here. This is the point. So this distance outside the two charges and near. So this means somewhere here lies now. This value small magnitude, that's why near to Q2. And this x distance, which will be equal to the distance d by, that is square root of big by small, big charge by small charge, big charge by small charge, minus 1. Yeah, you can tell me now here, which will be equal to d. How much the distance you can see now here, 12 by, that is square root of what we can say now, big by small. Big magnitude is how much you can say now, 4 Q0 by small magnitude is what, tell me now, Q0 minus 1. So what is this x value will come here? That is 12 by 2 minus 1, which will be equal to what? Tell me now here. 12 centimeters. That means this x value, how much now? 12 centimeters. The position of the proton from the origin. This is the origin now? Yeah, this is the origin. From where we should locate now this total distance. This distance they are asking now how much is value? That is 24 centimeters. The screen that side is also not visible for you. I will. Okay. Next, if two charges Q1, Q2 are separated by distance small d and placed in a medium of dielectric constant K, what will be the equivalent distance between the charges in air for the same electrostatic force? For the same electrostatic force, what will be the distance? Now here I have two charges. Let us say this is the two charges which will be given as Q1 and Q2 are the two charges, and these two are separated by distance d. These two separation distance d and placed in a medium of dielectric constant they given as a K. That means epsilon r value given as a K. Now what is the force between them here? Force in this case, this is F1 if I call. How much this value? Tell me. 1 by 4 pi epsilon naught K. Epsilon r is given K, and Q1, Q2 by distance is what? Tell me now. D square. Now second case, they change the medium between them. They given this as what to tell me now? 8 they given. So this is the distance d. Now they are asking how much this distance. This distance is r now, but this medium is 8 now. Now this F2, which will be equal to how much? 1 by 4 pi epsilon naught K value 1 for air, Q1, Q2 by r square. Now they are asking to find what? Tell me. Where this F1, F2s are equal. So that means both forces equal. For that, what will be the R value they ask him to find? Tell me now here. 1 by 4 pi epsilon naught K Q1 Q2 by D square, which is equal to 1 by 4 pi epsilon naught Q1 Q2 by R square. And do simplify and get it now here. 1 by 4 pi epsilon naught will get cancelled. Q1, Q2, 1 by 4 pi epsilon naught. So then, which will be r square, which is equal to k into d square. So this is r is equal to root k into d. So this is the distance. Root k into d. Next, two identical metallic spheres A and B, when placed at certain distance in air, repel each other with a force of F. Another uncharged sphere C is first placed in contact with A and then in contact with B, and finally placed at midpoint between the two spheres A and B. Then they ask you to find the force experienced by the sphere C is. This type of problem yesterday also we have handled. Yes, initially we have two spheres are there. So these are the two spheres we have considered. And so this is sphere A and this is sphere B, identical spheres. And so here, yes, if I call this will have equal charge now. This is Q, this is also Q. Yes, they repel each other with a force of F. So what will be the F you tell me now here? That is K Q square by R square. This is the force of repulsion. Now what they did now here, they have taken another sphere C, is placed in contact with A. When it is placed in contact with A, thereafter removed, and then what happens, you tell me now here? Charge of A will becomes what, tell me now? Q by 2. And in contact with the B, and this is placed in contact with the B now. B. Now in this case, when I place this are in contact now here, so this is B, this is C. Now C charge is Q by 2. B charge is how much here? Initially Q. After that, so what they did now, this A, now this is B and this is placed in between now. Here is A and this is C and this is B, and the charge is Q by 2. And this is Q plus Q by 2, that is 3Q by 2, that is 3Q by 4. And what about this one here? This is 3Q by 4. And this distance, how much they has given now? Half of the previous distance, that is R by 2. And this is R by 2. Okay. Now they ask you to find the force on C because of this A and B. And between this A and C, we have the repulsion. Now this is FAC, this direction. And this also positive charges only. This is FBC, the repulsion only. And the net force will be subtraction. So that means now this net force you tell me now here, it should be equal to what I can say now. This is FBC minus FAC. And so which will be equal to between them. So this is K into, so this is 3Q square by 8, distance that is R squared by 4, minus, oh this is FAC, sorry, this is FAC. FBC is what, tell me now here? This is 9K Q square by 4 square means 16, and this is R squared into 4 minus FAC 3K Q square by tell me how much now? 3K Q square by, so this value 4 into 2 8, R square 4 will come to numerator. Yeah, you can tell me now here if you have taken K Q square by R square, we have taken outside, and then will come to be a what, tell me? 4 fours, 4 twos. So will come to be a 9 by 4 minus what will be now 3 by 2. So which will be equal to what will be now k q square by r square. So this value for this LCM 9 minus 6, so 3. So this is 3 by 4. And this is the net force now. How much is net force we can say now? This is 3 by 4 into, this is nothing but initially F only. So this value how much now? 3F by 4. Okay. Next. A charge of 4 microcoulombs is divided into 2. The distance between the magnitude of the divided charge so that force between them is maximum. Yeah, if you remember, we did to have a force between them is maximum, the charges must be divided equally. To have force between two charges maximum, the condition is what we can say, the charges should be equal. Charges should be equal. So that will be given as what I can say now, Q1 and this is Q2. Both will be equal to what we can say now here, 2 microcoulombs. So option B. Next. 2 point charges Q each are separated by a distance d apart. Okay. A third charge Q is placed at a distance of x from the midpoint on the perpendicular bisector. The value of x at which charge Q will experience a maximum Coulomb's force. If we remember this thing, yesterday also we have did this problem. I have a charge, so here 2 charges are there. And these 2 charges are separated by distance of d. And now, so here this is the some charge of Q naught they has located. And they're saying that the 2 charges and the third charge has been located in this perpendicular bisector somewhere here. Perpendicular bisector means mid. Now, so this is x. Okay. Now this distance, this total distance is d, and this distance is d by 2. This distance is d by 2. Right. And this force, it should be this direction, and this force is this direction, and these horizontal forces will get cancelled here, and we have only the vertical forces. If I call this angle is theta, and this angle is also theta only, and this x direction forces, so here now if we resolve into components now here, so this angle also theta, this angle theta. So this component is what we can say here, F cos theta. And this component is what element now? This is F cos theta. And the net force is only upward directions. And this distance is square root of a square plus x square, where a is equal to d by 2. Okay. And so the net force which will be given us, what I can say, tell me. The net force which will be given as a 2F sine theta. 2F sine theta. And it should be equal to 2 into F is equal to KQ naught by what we'll get now here, root of A is equal to D by 2. Okay. Root of what will get, you tell me now here? A square plus X square whole square, then no root. And I can write it as a sine theta also will come, then it will come to be a x by opposite by hypotenuse, that is a square plus x square power 3 by 2. And this is the net force. I need to have this force must be a maximum. To have a maximum for the condition is what, tell me, will differentiate and will equate it to 0 now. So that is df by dx and will equate it to 0. So will come to be a q naught is a constant. To differentiate now here, a square plus x square power 3 by 2 into 1 minus, that is x into, this is 3 by 2 into a square plus x square power 1 by 2 into 2x by a square plus x square whole square means it will come to be a cube. Check this thing, all of you. Now I'll equated this force equated to 0. Then this 2 will get cancelled. So it will be a square plus x square power 3 by 2, which is equal to 3x square into a square plus x square power 1 by 2. Then it is a square plus x square, which will be equal to 3x square. Then it will be a 2x square, which is equal to a square. Then x is equal to what will be now here, a by root 2. And where a is equal to d by 2 now, so that means x is equal to d by 2 root 2. This is the x value. X is equal to d by 2 root 2. Okay. Next, a charge Q is placed at each of the opposite corner of a square. A charge Q is placed at each of the other two corners. Okay. If the net electric force on Q is 0, then Q by Q. And what they're saying here, so they has a square. Now here we have a charge of Q and here we have a charge of Q. Here we have a charge of small q and this is small q. And they are saying that the net force on the q is 0. So if I find the net force on this fellow 0, and because of this force is this direction. Okay. And because of this force is this direction. Of course, these two forces are equal. So if I call this is F1, 1, and this is 2, this is 3. And this is F2. And the resultant of these two, it could be like this. So this F12. And the third force is also like this. Yes, so if I call this all are positive charges. So this third force is also like this. Now we'll get this F1 value. F1 is how much you can say, which is equal to KQQ by distance, which is equal to A square, and that is also F2. Now we need what element now F12 required, so which is equal to angle 45 now. Angle 90 means it is root 2 KQQ by A square. And what about this F3 now here? This is KQ square by, this is root 2A whole square. Root 2A whole square. So that means F3 will come to be a KQ square by 2 into A square. This is the force, F3. Now, so they are saying the net force is 0 means I can say the net force, this is F3 plus F12. F3 plus F12 which is equal to 0. And F3 will come to be a what element now KQ square by 2A square. And F12, this is root 2 KQ small q by A square, which is equated to 0. Now, so K will get cancelled, A square, 1Q also will get cancelled. So what is left out now here? Q by 2 plus root 2 small q, which is equal to 0. So, now we'll get it as Q by 2, which is equal to minus root 2 into Q. Now, so how much is Q value? Tell me now here. This is Q by small q, which will be equal to minus 2 into root 2. So this is the ratio. Next one. Two spherical conductors B and C having equal radius and carry equal charges. Charges on them repel each other with a force F when kept apart at some distance. A third spherical conductor having same radius as that of B but uncharged is brought in contact with B, then brought in contact with C, and finally removed away from both. The new force of repulsion between them is right. Tell me now here. So initially we have the two spheres now here. This is now B, and if I call this as a C, and this is the B sphere, this is the C sphere. Equal charge. Let us say the charge is Q, and let us say the charge is also Q. When kept apart at some distance, and when these two are certain distance, the force between them, which will be equal to, that is KQ square by R square. Next, thereafter, what they did, you see this thing here. A third spherical conductor having same radius as that of B. Yes, so which is contact. So this is now B, and another one. So this is another uncharged one. is kept in contact. This is B, the charge is Q, this is 0. Now after separation, so what happens, you can see now here, when it is contact after separation, the charge will becomes what, tell me? The charge is Q by 2, the charge is also Q by 2. Let us say this is, we'll call it as A now, okay, A will call. Next, and this is in contact with the C now. This is in contact the C now here. So C initially having a charge of Q. When it initially contact, so when it is separated, how much the charge will contain now here? 3Q by 4 now, and separated here. This is also separated. Now, the charge is what, I'll be now 3Q by 4, and this is also 3Q by 4. And this is removed completely now here. And this one, this uncharged part, this is removed completely now. This is completely removed now here. They removed the charge completely. Now, and this, the distance between them is R. Now they are asking the force between these two. How much will come here? K into what we can say now, 3Q square by 8 R square. So that means the new force, which will becomes what, tell me now? K Q square by R square into what, tell me now? 3 by 8. Okay, so that means option D will come. Okay. Next. 3 charges minus Q and plus Q minus Q3 are placed as shown in figure. The x component of force on minus Q1 is proportional to x component of force. So this is, now here Q1, Q2. So we need the force on x component of force we need to calculate, right? So that is on where you need to find? On minus Q1. So this is between these two are positive or negative charges. So this means this force is attractive force. And if I call this is a F1. And so then these two is a repulsion here. Same polarity means this force is repulsion and this is F2. Right. And you can see now this is the y-axis and this angle is theta given. So we can resolve this into components now here. So what the net force along this x direction, you can see we need only x component only now. So that is what will be now here F1 plus F2 sine theta. So that means what I can say now, Fx equal to F1. How much is F1 force between these two? That is K. We have Q1, Q2. So this is K, Q1, Q2 by distance is how much between them is a B square plus. And what about this F2 here? This is F2 means how much? This is K, Q1, Q3. This is small q. This is Q1, Q3 by distance is A square into sine theta. So that means this Fx which will be equal to, this is KQ1 into, we can place now, this is Q2 by B square plus what tell me now here, Q3 sine theta by A square. Check this thing. Now they are asking it is proportional to what, tell me, Q2 by B square plus Q3 sine theta by A square. So option C I can see now. Next, if a charge QB is placed at the center of the line joining two equal charges Q such that the system is in equilibrium, the value of Q is, okay, I have a charge QB is placed at the center. I have the charges we have. If I call this is a Q and this is also Q, and so these two separated by some distance of D. To have the equilibrium point, we should locate the charge must be located at the midpoint. This is my third charge, that is Q naught. And so they are asking the value of Q naught value. Yes, Q naught, which will be equal to, that is Q1 Q2 by, so square root of same polarity, Q1 plus square root of Q2 whole square. So that is Q naught, which will be equal to QQ. So this is what tell me now here, this is Q square by, that is root Q plus root Q whole square, which will be equal to what tell me now here, Q square by, so 2 root Q whole square will come to be a what tell me now here, Q square by 4 into Q will come to be a what tell me now here, Q by 4. And we need to see the what will be the polarity, positive or negative. Agar if it is a positive I to kya hoga, you tell me now. So this is a charge 1 and this is the second charge. Now, and this is a third charge. Between 1 and 2, we have these forces like this, F1, 2 and 2 and 3. Also this direction only na. So these two forces will never get cancel each other. So इसीलिए अगर इसको हमने नेगेटिव ले लिया तो क्या होगा, टेल मी नाउ. Then there is attractive force now between 2 and 3. So this force is, and here this force is this direction, F2, 3. Isn't it? So from this, what happens? You tell me now. This is will get cancelled now. So the third charge Q naught must be equal to how much now? Minus Q by 4. Next. Yeah, take the next one. The three charges Q by 2, Q and Q by 2 are placed at the corners A, B, C of a square of side. As shown, the magnitude of electric field at the corner D. They ask them to find the magnitude electric field here. Now, if we call this is, let us say 1 and this is 2, this is 3. So let's find this electric field because of this one, this directions. And because of this is this directions. And so this, if I call it as a E1 and this electric field is a E2. Now you can tell me now here this is E1, which will be equal to what tell me now here, this is K into, so this is Q by 2 by distance A square. So this is KQ by 2A square. And what about this E2 value? Tell me. That is also KQ by 2A square. And what about this as a B and D here? This is these directions. And the resultant of these two we can find. Resultant of this E12, which will be equal to root 2 KQ by 2A square. And what about this as this is 3 E13. Okay, now this E2 which will be equal to, that is KQ by, that is root 2 A whole square, will come to be a KQ by 2A square. So the net electric field which will be given as E13 plus E2. So that is, which is equal to KQ by A square we have taken common, then it will becomes 1 by root 2 plus 1 by 2. Check these options. What we have? Yes, so option A. Right. Done. Got it. Fine. Yeah, that's it for today. So we will see the remaining problems in the next class. Same manner will continue daily. Okay then. See you. Bye-bye.